when this is in factored form, now one thing you'd want to pay attention to here and be really careful of is if this 3 right here had an x on it, we would also have to set it equal to 0, okay? Because that's considered to be like our GCF. This does not have an x on it here, obviously, so there's no reason to set it equal to 0 because it's just a number. You can't set it equal to 0. But in some cases, it could have an x. X plus 6 has to get equal to 0. X minus 6 gets equal to 0. My multiplicity is simply the exponents, okay? So when it's in factored form, much better way and much easier way of finding the zeros in the multiplicity. If it's in standard form, that's a little bit more work. The one that was missed more on the quiz was the one that was in standard form because you had to go through and find the other zeros. We had one like this on the quiz. Just be careful, like this one's a little different. The one that we did on the quiz like this, it gave us the height, so we plugged it in for s, because s is the distance or height of the object. In this case, it says t is the time in seconds, how far will the object travel, and so it's giving me the time. So all we got to do here is just take 18, plug it in for t. So pay attention to if it's distance or if it's time, okay? And that tells you where you plug it into. If this was the distance or the height, we would plug it in here, we would move it over, and then we would solve it. And probably just graphing it would be the best way to go. But if they give me time, we plug it in, and you're trying to figure out how far this object will be or will move. Okay. A helpful hint on this one here is look at the graph, the window that you would want to use in your calculator, especially if you just use your standard window, it will not look very good. And it's going to give you a really distorted view of the graph. So notice that your x values go from -6 to 6. If you left it from -10 to 10, your normal window, I think that would be okay. But your y probably needs to change. And just put in the window that we have here. My y min starts at -200. It's the lowest value. So just go into your window, change the y min to -200, change the y max to +200, and then you have your y scale, and this is going up by 40s. That's going to give you a lot better view of the window, of the graph, okay? If you don't change your window, then it's not going to look like it should. And it's going to be really hard to determine like what your zeros are and stuff. Now, I will tell you this, because this is in factored form, you should be able to determine a lot of stuff without even graphing it. I don't have a problem with you graphing it, obviously. But just some things, and this is probably more so what this problem is all about. This one's going to have a 0 at 0. It's going to have a 0 at -3 and a 0 at 2. So -3, 0, and 2 are my 3 zeros. Those are the 3 places they should cross or touch the x-axis. Here, my multiplicity is 1. Okay, so even though it's not asking us to identify the zeros and the multiplicity and all that, all of those things are helpful when looking at a picture of the graph. Okay, so this one tells me it's going to go through the x-axis at 0. When it has a multiplicity of 2, what's going to happen? It's going to bounce. Okay, so it is not going to go through the x-axis at -3 and 2. It's going to bounce off the x-axis, where it's going to come hit and it's going to come back down, depending on what direction it comes from. Okay, so all of those things should kind of tie in with what you're doing. Can you just put it into the calculator and sketch a graph? Sure, but you should also be able to make sure all that fits along with it as well. Doesn't take much time to do all that, and then that should kind of help you get a good idea of where the graph should hit the x-axis and things like that. So some things that you can use there to kind of help you guide the graph. The graph doesn't have to be a perfect match, right? And I'm not really looking at like minimum and maximum values there. where it crosses the x-axis and the basic shape of the graph is really the biggest thing there that we're looking for. Hey, I told you that I would not make you do long division, so you do not have to do long division. You can do synthetic division. Now, if you really want to do long division and you got a burning desire to do it, go for it. But I'm thinking most of you guys are probably going to choose synthetic. Okay, one thing on number 7, you guys did a pretty good job, I think, when doing synthetic division. This one, first of all, in the box is going to be a -3. And then we got a 2, a -1, a -15, a 3. And notice that it's missing a constant. It doesn't have a number at the end. So we have to put something in for the constant, which is 0. So if it's missing a variable, an exponent, we got to put in a missing place value for that. 0 is the missing place value. If it's missing a constant, that has to come at the very end. And then I'm going to go through synthetic division. Okay. Now remember, and we've talked about this before, but will I get a remainder of 0 here? Do I have to get a remainder of 0? No. Not necessarily. Okay. Could I? Maybe. But don't get freaked out if you don't, because the only time I have to get a remainder of 0 is if it tells me that it is a 0. If I said -3 is a 0 of this polynomial, I have to get a remainder of 0. If it doesn't say that, then we probably won't get a remainder of 0.
On 6, we use synthetic, do we still have to put it in that form that wants the answer in?
Not necessarily. No, you can just do your normal form. I'm not too worried about that. Okay, number 8, and I've talked about this a lot too. You have 2 options on number 8. I know it says to use synthetic division, so you can obviously use synthetic division, okay? But if you would rather just evaluate f of 2 and take 2 and plug it into the function, I'm okay with that either, okay? I don't really care which way you do it. If you do synthetic division, your answer is your remainder. If you plug 2 into the function, then obviously your answer is what you get when you plug 2 in, okay? So either one of those are perfectly fine because we've done both throughout the chapter. Should get the same answer either way. Okay, this is the one that we talked about on the quiz also. And I told you that this is not going to factor. The only way we know how to factor this one is grouping, and grouping does not work on all of these. And this one is one of those that does not work on. So put it in the calculator, but just make sure it's asking 2 things. It wants us to factor it, and it wants us to solve it. So when we factor it, we're going to have 3 factors. And then when we solve it, we're going to list out the 3 values that it crosses the x-axis. So you can do it completely in your calculator. What we would do here is we would solve it first, list out the 3 zeros because it's a cubic polynomial. What are the 3 zeros? And then rewrite those as factors. Okay. So that one, you can strictly just do it on your calculator. Hey, on number 10, I do want you to show synthetic division on this one. And it may only be synthetic division one time. But the one that we did on the quiz like this, bless you, we ended up getting an answer that was a fraction. And it crossed the x-axis there, and by going through synthetic division, it can kind of help you to break that polynomial down and get to those zeros. Okay, so don't forget to graph this one as well. That's part of this problem too. That's why the graph's there. There's a few people on the quiz that just found the zeros and then didn't graph. So show the relationship between the two. And somehow you have to account for 3 zeros because we have cubic. Does that mean it's going to cross the x-axis 3 times? Not necessarily. Okay, so we got to find all 3 of the zeros and then account for where they are. If you have imaginary zeros, you got to account for the imaginary zeros. If you have one that bounces, you got to show that it has a multiplicity of 2. If it crosses the x-axis 3 times, then that's pretty straightforward. So a lot of different possibilities there. Okay, we had a couple of these on the quiz. There's only going to be one on the test. I know we kind of struggled with these a little bit, just the foiling part. And remember that, like, when I multiply negative I times positive I get a negative I squared, but I squared is really negative 1. A couple chapters ago we talked about anytime I see I squared for the rest of the semester, we need to know that I squared is really negative 1. Okay? So I would always make sure you do the conjugates first. So do these two first, and then you'll have to do FOIL one more time. Okay. Aubrey, question?
Nope, I'm good.
Sure. This part here just is telling us that it's a degree of 3, so make sure at the end your answer is a cubic polynomial. Okay, it'll be x cubed. Okay, we had one like number 13 on the quiz. Just put negative 3 in your synthetic division. Go through synthetic division, you're going to break it down. And then, and just like the quiz, I think this one is imaginary zeros. If we do one like this, it probably tells us that the zeros are imaginary or maybe radicals, and we got to use the quadratic formula to get there. Okay, there's not really any formulas that you need for this. The quadratic formula is still on the board, but most of the form, I don't think there's really anything that you need. All right, so starting pretty much at 18, these are the sections that were not on the quiz, talking about asymptotes, a little bit of graphing these rational functions. So vertical asymptotes, just remember that you're going to set the denominator equal to 0. If it's not already factored, you want to factor it. This one's already factored, so just set the 2 equal to 0 and get your vertical asymptotes. Horizontal asymptotes, that's the one that has the 3 rules. So you may want to go back and remember those 3 rules. And it's always based off the degree. If the degree is bigger on top, if the degree is bigger on bottom, or are they the same? So go back and review those 3 rules. Then we got a couple of graphing. And these are all ones that are just a little bit different. Number 20 is, I think, pretty straightforward. Things that we're looking for. We had that big long list of things that we talked about whenever we graphed these. So things that I'm going to be looking for here when you graph these. What is the vertical asymptote? Are there any holes? The horizontal asymptote, the x-intercept, and the y-intercept. Those are the 5 key points or parts that we're looking for when we graph. Okay. And so 20, 21, and 22, all 3 of those, we're looking for those 5 things. Can you give me other points and things like that? For sure, but the asymptotes are a really big deal, and then the x-intercept and y-intercept just kind of help you guide the graph a little bit. All right, so let's do number 21 together, just because it has a little bit of everything in it. We're going to factor the top. It stops. So we're going to factor it into x plus 3 and x minus 3. Sometimes it's already factored, sometimes it's not. If it's not, we want to go ahead and factor it. Okay, so if we write out okay, and I will tell you this. Even though we're writing these 5 things out, that doesn't mean you're going to have all 5 things included. Sometimes there may not be an x-intercept. Sometimes there may not be any holes. So there may not be anything there, but we got to check for it. Okay. So on vertical asymptotes, and this is where this one gets a little bit tricky, and this is why even though I list vertical asymptotes first, we should always look at holes first, because I noticed right away that x minus 3 is a common factor, okay? So if there's a common factor, then my hole here would be at x equals 3. I'm going to set x minus 3 equal to 0, and my hole would be at x equals 3. We don't see this very often, but this one does not have any vertical asymptotes, because the only thing that we have on bottom is x minus 3, and it's a hole, so that it can't be a vertical asymptote in a hole. Okay, it's one or the other. So that's a little bit different. Most of the time we have a vertical asymptote. Horizontal asymptote, sometimes you have one, sometimes you don't. Okay, the rule for horizontal asymptote, if my degree on top is bigger than my degree on bottom, it was 2, and the bottom is 1. So if the degree on top is bigger than the degree on bottom, then there is no horizontal asymptote. So this graph has no asymptotes, which is kind of weird. Most of the time when we graph a rational function, it'll have at least one of the two asymptotes, and sometimes both. Okay, for the x-intercept, we're going to take anything on top and set it equal to 0, but x minus 3 was a hole, so we've already set it equal to 0. So the only thing left would be x plus 3 equals 0, which gives me x equals negative 3. So it's going to cross the x-axis at negative 3. So if it's a hole, we can only use that for the hole. We can't use it for anything else. Okay, for the y-intercept, we always plug 0 in for x, and we find out what y is. So if I do that here, 0 squared minus 9 is negative 9. 0 minus 3 is negative 3. So really, negative 9 divided by negative 3 would be 3. So this one's going to cross the y-axis at 3. Okay. Now, remember, this one doesn't have any asymptotes. Okay? And I'm going to show you really quickly here. Graphing this one should be pretty easy, because if I knock out those x minus 3's, I don't want to do that at the beginning because I want you to get all the information first. But if I knock these two out, because they're common factors on top and bottom, then all I have left is x plus 3. So when I graph this function, if I were to graph x plus 3, what kind of graph would that give me? It's just a linear function, slope-intercept form. Okay? It has a y-intercept at 3, and it has a slope of 1. Well, we've already found that it has a y-intercept at 3. So what you could do is you could just go up 1 over 1, up 1 over 1, and get a bunch of points. And what you have to remember here is that it has a hole at 3. So wherever, we're going to go up from 3, and we're going to put a hole in the graph. So it's just a linear equation. Hey, can you put that into your calculator right from the start? Sure. Okay. And if I do that, let's say I put that, we had x minus 3 on bottom. If I put 3 in for x, that gives us 0 in the denominator, and we can't ever have 0 in the denominator. So it either has to be a vertical asymptote or it has to be a hole, one of the two. Questions on that one? Hey, this one here, go through all of the same things again. Vertical asymptote, hole, horizontal asymptote, x-intercept, y-intercept. In order to find the vertical asymptotes here, this is not factored, so we got to factor it. What am I going to have to do to factor that? Is there a GCF? Yeah, if there was, that would be first thing. But there's nothing I can take out. I got 3 terms. Can I do product and sum here? No. I can't do product and sum because we have a number in front So what factoring method are we going to have to do? I know you really don't want to say it, probably too bad, but doesn't mean we aren't going to do it either. Slide and divide. Good old buddy slide and divide. We haven't seen it for a little while. Okay? You guys want to go through slide and divide? You remember how to slide and divide? Yes? No? Yes? Okay. 2x squared minus 5x minus 3. Okay, my product is the outside two numbers, -6. My sum is the middle number, which is -5. Okay, very similar to product and sum. The only difference is we multiply the outside two numbers to get our product. If I just did regular product and sum, it would just be -3. So that's really the only difference. Okay, now, what two numbers multiply to get -6 and add to get -5? -6 and 1. Okay, so the way that we write it is x minus 6 and x plus 1. And what I do is I write them as fractions because there's a number that goes on bottom of each one of those. Because x minus 6, x plus 1 is not our factors. It's because we have a number in front. The number that we put on bottom is that coefficient, the number in front of the x squared. So we put a 2 under each one of those. If it reduces, then we reduce it. If it does not reduce, then we slide it over and put it in front. These two things should multiply to give me that. Not that you have to check that, but that's where the factors come into play, right? These are the two factors that multiply to give me that. So these are now my two denominators. So I'm going to set both of those equal to 0, and that would be my vertical asymptote.
Where did the 2 come from?
This right here,
The double 6 divided by 2.
6 divided by 2, that is the leading coefficient. It's the number up front. That's what we're dividing by. I'll always, I can't just leave my answer like this, because x minus 6, x plus 1 would not get us back to here because of that leading coefficient. So
What
the
did we
leading,
need to get sum for then?
what's that?
Why did we need to find the sum?
Okay, so we got to write this out first. So we got to find two numbers that multiply to get -6 and add to get -5.
Okay.
So that's where the -6 and 1 comes from.
Okay.
And those are the two numbers that we're going to divide by 2. Yes? Does that make sense, Andrew? Marnie?
How do we get the, like, how do we use the -5? Are you just using the b term?
How do we use the -5?
Yeah, where do we get that?
It's just our sum.
So just the
Yeah,
b term.
it's just the number that they have to add up to be. So -6 times 1 would be -6. -6 plus 1 would have to be -5. So those are the two things that we need to get to. Okay, what other questions on that one? Okay, and the reason why that's extremely important is because when you graph this, how many vertical asymptotes am I going to have? We're going to have 2 of them, okay? One of them is going to be at -1/2 because I'm going to subtract this and divide by 2. And that's going to be kind of difficult to find just on your calculator, okay? So being able to find that without just looking at the calculator, kind of a big deal. Okay, any other questions on that one while we're there? I'll let you finish that one out. If you have questions or if you need some help on it, let me know. These are the ones that we did yesterday, other than number 26. So we have 3 questions dealing with inequalities. It's asking when is that function less than or equal to 0? So when is it below the x-axis? Okay, this is a rational function. critical values, okay? A critical value, they call it a little bit different here, but we call it a lot of different things. So a critical value is simply a restriction. What can X not equal? That is a critical value, okay? So in this case, in this function right here, what would be a critical value of X? 6, okay? And that's my only critical value. So if I look at the first question, identify the critical value of the function. This one has -6 and 6. Nope, we don't have two of them. This one has -6. No, this one has 6. So by process of elimination, because it's multiple choice, this is the only one that has the correct critical value. And then if you want to graph it, you can. We did one like this yesterday in our notes where it's a rational function that has like asymptotes and it has some curves, and you can figure out the second part. But just by process of elimination, we can get to the part that it's B, and you probably don't even have to put it into the calculator. But if you had two of them that had the same critical values, then you'd have to do a little bit of work to figure out what the solution would be. Okay, 25, just make sure that you solve it first. So this is going to be x squared minus 5x plus 15 is less than 0. Get x, or set it equal to 0, or in this case less than 0, and then you can use your calculator to help you out from there. I'm wanting to know, when is this function less than 0? When is it below the x-axis? A couple people asked me about this when correcting the quiz yesterday, because we had one very similar to this. You can really just use your calculator on this, and especially because it's multiple choice, you're just kind of doing a process of elimination. Now, the one thing that's kind of weird here, and I don't really know why it's written like this, I think it's just probably an error in the program, I'm guessing. But if I were to take the square root of 4, what would the square root of 4 really be? 2, right? So really, this would be -2. So this is saying -2 is a solution with the multiplicity of 2. -3 is also a solution. So I don't really know why they write it as radical 4. I think it's just a program thing where they punch a number in there, and that's what it comes out as. But I mean, it makes sense for a radical 3 to have a radical on it, but typically if we have radical 4, we'd simplify that to be 2. Okay. Any questions that you guys have so far? All right, I'm going to kind of come around. I'll help you out.